This is part one to section 2.1, change in arithmetic and geometric sequences. So in this video, we are going to focus on arithmetic sequences. So a sequence is a function from the whole numbers to the real numbers. So what this means is that you're only able to plug in whole numbers, and whole numbers are 0, 1, 2, 3, so on and so forth, into a sequence, but any real number can be the output. So as a result, when we graph a sequence, we will have points, but we cannot connect them together to form a line or a curve. So in example number one, consider the sequence defined by a sub n, that means subscript n, equals 4n minus 3. We want to find a sub 1 and a sub 7. So to find a sub 1, all we're going to do is plug in 1 n for the variable n. So that would be 4 times 1, which is 4, minus 3. So we would get a sub 1 equals 1. Then we would do the same thing for a sub 7. And so we would get 4 times 7 minus 3. So that would be 28 minus 3. So a sub 7 is equal to 25. Okay. So in this course, we're going to talk about two different sequences, arithmetic and geometric. In this video, we're going to focus on arithmetic, and in part two, we'll focus on geometric. So, property of successive terms. Successive terms mean one right after another. So first term to second term to third term. Okay, you're not jumping from the first to the fourth and then to the ninth. Okay, it's first to the second to the third, fourth, so on and so forth. So successive terms have a common difference. Okay, a common difference or a constant rate of change. A common difference is the number that we're going to identify that is adding or subtracting to get the same or to get the next term in the sequence. So you will add or subtract or add a negative to get the next term in the sequence. So with arithmetic sequences, we have a couple different formulas. We have this first formula right here, where it's a sub n equals a sub 0 plus d times n. So this is used when you know the zero term and you know the common difference. Okay, and n is just your variable. When you don't know something, you will typically use this second equation, where you can plug in any term you want for a sub n, as long as this subscript matches this right here. So if you have the second term, this will be a 2, and this will be whatever the second term is. And if you know like the 17th term, this would be 17, and this would be whatever term that is. Okay, so a sub 0 is going to be known as the initial value, which is also like the y-intercept. D is our common difference. That's the variable we'll use to denote the common difference. And a sub k is the kth term in the sequence. This will be the same for a sub n as the nth term in the sequence. Okay. Some other notes that we have is that arithmetic sequences behave like linear functions, except they are not continuous. They're not continuous because we're not connecting the points. Okay, that has to do with the input being whole numbers and the output being real numbers. Increasing arithmetic sequences increase equally each step. The slope always stays the same. Slope always stays the same. Okay. So here we go on our first example. What we want to do is we want to plot some points to get this graph. So we need to plug in some values. So first, let's plug in 0. So if we find a sub 0, that means we would take 3 times 0 plus 1. That would be 0 plus 1, which is 1. So we would have a point at 0, 1. So the input value was 0. The output value was 1. Then we can find a sub 2. That would be 3 times, not 2, I'm sorry. we have to do successive terms, so it should be a sub 1. So we would do 3 times 1 plus 1. So 3 times 1 is 3, plus 1 is 4. So we would get the point 1, comma 4. Then we would do a sub 2. That would be 3 times 2 plus 1. So 3 times 2 is 6, plus 1 is 7. So we would have the point at 2, comma 7. And then the next one, if we were paying attention, notice that we go from 1 to 4, that's just adding 3. 4 to 7, that's just adding 3. So if we continue this pattern to find our third term, we would just add 3 and we would get 10, and we can't graph 10. Okay, so you can plug it in some points or values, and then you could also recognize the pattern. Notice that the common difference comes from right here. And then, so that was our variable D. This right here represented the initial value. Okay, and that's where our y-intercept was. So in this next example, for each of the following, determine if the sequence could be arithmetic. If yes, identify the difference. So first thing you could do is you could say, well, this right here is a quadratic because of the x squared. So right there, that should tell you that it is not going to be arithmetic, because we said arithmetic behaves like a linear function. Okay, but if you were not sure about that, what you could do is you could plug in some values. So we could plug in 0, and we would have 0 squared minus 3. That would give us negative 3. Then we could plug in 1. That would be 1 squared minus 3. That would be 1 minus 3, which is a negative 2. Then we could plug in 2. That would be 2 squared minus 3. That would be 4 minus 3, which is 1. And so if you look, to go from term to term, here we're adding 1, but here we had to add 3. So we're not adding the same amount each time. So this is not arithmetic because there's no common difference. Okay, looking at this next one, you should recognize this equation right here as a linear equation. Okay, but if you weren't sure, you could plug in some values. So plug in 0. 0 minus 2 times 0, that would be 6. 6 minus 2 times 1, that would be 4. Sorry, that should have been a 1. Plug in a 2. 6 minus 2 times 2, that would be 2. So if you notice, from 6 to 4, you subtract 2. From 4 to 2, you subtract 2. So that would be the pattern. So this is arithmetic. And the common difference is a negative 2. Looking at the next one. So this time we actually have a sequence listed out. So how can we go from negative 7 to negative 2? You could do negative 2 minus a negative 7, and that gives you a common difference of a positive 5. So from here to here, we add 5. If we add 5 again, we should get 3, but you could also do 3 minus a negative 2, and that would get you 5. And then 3 plus 5 is 8. 8 plus 5 is 13. So yes, this is arithmetic. And the common difference is 5. Looking at the next one. To go from 1 to negative 2, that would be minus 3. To go from 2 to 3, negative 2 to 3, that would be plus 5. So that's enough to tell us that this is not arithmetic. So there is no common difference. Okay, now looking at the next example on the next page. Example 3, let a sub n be an arithmetic sequence with a sub 3 equaling 8 and d equaling negative 3. Find an expression for a sub n and use the expression to find a sub 12. So we want to know what the most important information is. So the most important information is that this is an arithmetic sequence. Okay, and we know that the third term is 8, and we know that the common difference is negative 3. So the very first thing we want to do is we want to find an expression for a sub n. Okay, so because we're not given the zero term, we are going to use the second equation. A sub n equals a sub k plus d times n minus k. So we plug in our values. So we know that the third term is 8, so a sub k, or k, can be 3, which means a sub k is 8. So we would get a sub n equals 8 minus 3, because that's our common difference, times times n minus 3, like that. So that could very well be an answer. You could also have this simplified. So if this were simplified, we would get a sub n equals 8 minus 3n plus 9. You will have to distribute the negative 3. You cannot add 8 and negative 3 or 8 and 3 or subtract them because the 3 is being multiplied. So you have to distribute this first, and then a negative times a negative is how we get a positive 9. We combine our like terms. 8 plus 9 is 17 minus 3n. So either one of these would be acceptable. This would be an acceptable answer, and this would be an acceptable answer. Now you can use that equation to find the 12th term, because that was the second one. Find a sub 12. So a sub 12 equals 17 minus 3 times 12. That would give us 17 minus 36. And so a sub 12 would equal a negative 19. If you wanted to use the first highlighted equation, you would get the same answer. So just to show you this one time, 8 minus 3 times 12 minus 3. This would be, that should be a 12. This would be 8 minus 3 times 9. That would be 8 minus 27, which is a negative 19. So it doesn't matter which equation you use, you get the same result. Looking at the next one, let a sub n be an arithmetic sequence with a sub 2 equaling 7 and a sub 6 equaling 9. Find the expression for a sub n. Use the expression to find a sub 24. So there's a couple different ways you could go about this, but first we need to identify our important information. So we know that we're working with an arithmetic sequence. We know that our second term is 7. We know that our sixth term is 9. We want to find an expression for a sub n, and then use that expression to find a sub 24. So there's more than one way to go about this. I am just going to show you one way. So the first way you could go about this is using this equation right here. And so we're going to plug in what we know. I'm going to, for this one, let k be 2, and n be 6. So that means a sub n is 9, a sub k is 7. We do not know the common difference. N we said was 6, and k is 2. And so now we can solve for our common difference. So if we did this, we would get 9 equals 7 plus 6 minus 2 is 4 times d is 4d. So now we can subtract 7 from both sides. We would get 2 equals 4d. Divide both sides by 4. D is equal to a 1/2. And so now that we know our common difference, we can write our equation for a sub n. So whenever you go to do this part, it does not matter which point you use. Because I've already used 7 and 2 for a sub k and k, I'm just going to stick with that. So I'm going to have a sub n equals 7 plus our common difference times n minus 2. That would be an acceptable answer. And then if we simplify this, that would be 7 plus 1/2 n minus 1 because we distribute the 1/2. Then I can combine like terms and I would get 6 plus 1/2 n. So this would be an acceptable answer. This would also be an acceptable answer. And then again, you could use the other point. A sub n equals 9 plus 1/2 times n minus 6. And if you were to simplify it, you would get the same equation. So that would be another acceptable answer. Okay, now for a sub 24, I personally would use the simplified version, but you can use any of the highlighted versions. So a sub 24 is equal to 6 plus 1/2 times 24. Half of 24 is 12. 6 plus 12 is 18. Okay. And then last but not least is writing the equation from a graph. So notice how we have several points here. So you could write a different equation that is equivalent with every single one of those points. But all you need is a point and you need a common difference. So the easiest one to do is using the y-intercept. The y-intercept is a sub 0, which equals 8. But you do need to find the common difference. So my common difference, we go down 2 and over 1. So the common difference is equal to a negative 2. So one correct equation would be a sub n equals 8 minus 2n. You could have a sub n equals, I have a point at 1, 6. So we could have 6 minus 2 times n minus 1. We have a point at 2, 4. So we could have 4 minus 2 times n minus 2. We have a point at 3, 2. So another correct point would be 2 minus 2 times n minus 3. And then we have a point at 4, 0. So that could be a sub n equals 0 minus 2 times n minus 4. All of those would be correct answers, so you would just need to recognize all of them. So if you have any questions over 2.1 part 1, please make sure you reach out so I can help you out.